So the last day we looked at the adaptations of alveoli, and before we start I would just like to show you this video. So this is a video endoscope going down the trachea of a horse belonging to a friend of mine, and they've allowed me to use it. And what you can see is that you can see the kind of green snot down here, the mucus. So this animal is sick, hence they have a video camera down their throat. But you can also see the fact that it's very, very moist down here. So remember all those things that are going to help gas exchange. You can see the tube is getting smaller as you look down the endoscope, and that it's moving. So there's elasticity to it. So this is somewhere between bronchus and bronchiole in this particular animal. So that's just a reminder. So he is not healthy. Now today we are going to look at the process of inhalation. The word is really, really important. You have to recognize in a question what they mean when they say process versus what they mean when they say pathway. So pathway is going from your nose down your throat, your trachea, your bronchus, your bronchioles. It is how oxygen is getting into your lungs. Whereas the process of inhalation is why does the air actually go into your lungs? What is going on to make that happen? So there's a big difference between process and pathway. So before we start and get into that, we just need to talk a little bit about the composition of air. So this is roughly on page 144 of your notebook, and you may already have an idea of what things are in air. So we have oxygen, carbon dioxide, we have nitrogen, and we have water vapor. In terms of the percentage, so there's 21% oxygen in air. Carbon dioxide in inhaled air is very small. It's practically negligible, but it is there. Nitrogen is present at 79%. Now, nitrogen does nothing for us. We inhale it, we exhale it. The concentration never changes. Just as useless piece of information, if you open a bag of crisps, Tate's, whatever, hula hoops, or you sit in it and you hear the pop, you've actually just released nitrogen out. They put it into crisps to keep them fresh because it does nothing for us. And the only time it becomes an issue is if you are diving in the ocean and you come up too fast. Then the nitrogen becomes a gas again in your muscles, and it's called the bends, and it's not fun. The water vapor will obviously depend on what type of day it is. Very hot day, very dry day, the water vapor will vary. Now in exhaled air, there is obviously a loss of oxygen because it's going into our blood. There's 16% oxygen in exhaled air, so this is why if someone has a heart attack and you have to give chest compressions, they say you should give 30 chest compressions before you give 2 breaths, and this is the reason you can do that, because there is still oxygen in the blood, so that is still going to be able to diffuse into cells if you're doing the chest compressions as the pump. So obviously then the increase in carbon dioxide has to happen because that's being now removed from your blood when you exhale. The nitrogen is going to stay the same, it's a constant, and your water vapor, well, you'll get as much water vapor out as you can. So Irish people really understand the word saturated. If you're stuck in the rain and you're saturated, you're just soaked to the skin. Similarly with exhaled air, it'll fill with as much water vapor as it can get out. And you only need to breathe on your mirror to see it condense, and you're looking at the water vapor. So take the time now to fill in your little table, and these are just in words. So it's really the oxygen and the carbon dioxide concentration of inhaled air and exhaled air that is different. So in terms of how is oxygen transported, well, it's all dependent on your red blood cells. So we have a chemical, it's called hemoglobin in your red blood cells, and that literally grabs onto the oxygen when it diffuses into your blood. And once the oxygen and the hemoglobin bind together, it's called oxyhemoglobin. And the vast majority of our blood is carried in our red blood cells. There will be the smallest bit carried in the plasma, which is the liquid portion of your blood. In terms of then carbon dioxide doesn't need anything to carry it. It is found in the plasma, and it's either as dissolved carbon dioxide or as bicarbonate ions. There will be a teeny tiny percentage carried by your red blood cells, but none that's not a very high number. So we're going to have a look at this video and get an understanding of why is it that air will move into our lungs in the process of inhalation.
To understand how we breathe using the lungs, we've got to have some understanding of pressure. Now let's look at a simple example. Imagine a little food bag, the sort of thing you might pack your sandwiches in. Imagine that we pull on this in every direction. We know that it is then going to fill with air as a consequence. Now what's happening? Well, we've increased the volume, and what this has done is it has decreased the pressure inside of the bag. Now that decrease in pressure immediately balances itself out by filling the bag with air to then rebalance that pressure. Now let's contrast this with a slightly different example. Remember, with this food bag example, an increase in volume will decrease the pressure inside. Now let's look at a balloon. Now with a balloon, we put air inside and the balloon will expand. An increase in pressure increases the volume. People often make the mistake of thinking that with your lungs, you force air inside and that makes your rib cage, your chest expand. And that's not true. Your lungs behave the same as the food bag example, that what we are doing is we are forcing it into a bigger shape, and that forces the air to enter. Let's have a look at the structure of the lungs here. Now, first of all, we've got to think about the diaphragm. What will happen is the muscles of the diaphragm will contract and move down. Let's look a little bit more closely at what that is. This sheet of muscle will contract, and that makes it move downwards. So this is going to help to increase the volume inside of the thoracic cavity. Next, let's think what's happening with the muscles that are attached to your rib cage. The external intercostal muscles are going to contract, and this will pull your rib cage upwards and outwards. So altogether, these movements will create an increase in volume. An increase in volume decreases the pressure inside, and just like the food bag example, this causes air to enter the lungs. By contrast, when you breathe outwards, the diaphragm will then relax.
Okay, so we are going to have a look at inhalation first, and then we'll come back to that. So I use the ICC-DIDI as my kind of cheat way to talk about the process of inhalation. So the I stands for inhaling, and the two C's stand for contract. So the two things that contract are the intercostal muscles and the diaphragm. And when both of these things happen, the diaphragm moves down. As you saw in the video, that means there's an increase in lung volume, a decrease in air pressure, and the air moves in. Now literally, these guys here are full marking points. So here is that air moves in, is the last marking point. The only thing that ICC-DIDI doesn't take into account is this beginning bit here, if you want to put it in. So I'm going to make it a plus up here. So it is the fact that your brain sends an impulse to the diaphragm and to your intercostal muscles. So that's like the beginning of the story. And the only other thing that isn't included here is what happens to your ribs, because I couldn't figure out how to write all that in. So here, your ribs, and you can do this by just inhaling, your ribs move up and out. But as I say, these points over here, the ones that I've bulleted in for the ICC-DIDI, well, the CC-DIDI will hit pretty much most mark schemes that want to know about the process of inhalation. So again, if you need to write this in here and highlight for yourself, the question is going to ask about the process, not a pathway. Okay, so if you start talking about, oh, air goes into your trachea and into your bronchus and into your bronchioles, that's going to give you 0 marks. Okay, it is the process of inhalation we are interested in. Now, you are going to have a quick peek at this video, and then you're going to do a little bit of thinking for yourself, because I know you can do this. So we'll look at this.
Now for a spectacular biological hack. Rachel Peterson from Washington State wanted to show her kids how lungs work. So she purchased some cow lungs from her local butcher and attached a leaf blower.
Lungs just look weird. But then again, I guess they weren't designed to travel around without the rest of the cow attached.
Some people might think this looks a little bit gross to see these lungs being inflated on the table, but to me as a biologist, I think it's amazing to see how this organ really works.
When a cow breathes, it's taking in oxygen through its bronchial tubes. And it goes through the bronchial tubes and into the lungs and into these tiny, tiny little tubes called alveoli. And the purpose of the alveoli is to increase the surface area where gas exchange can take place.
We're talking up to 500 square meters of surface area within a lung. And this is to be able to transfer oxygen into the tissues and to allow CO2 or carbon dioxide to transpire out of the tissue. So surface area is really critical in the lung.
So Rachel's leaf blower replicates breathing on a table. But these lungs look like they could burst. Would they ever really get this big?
An ordinary breath for a cow is about 1 gallon of air, or 5 liters. But when you take the lungs outside the body and attach this leaf blower, you can inflate them to about 4 times that size.
Now that's some serious lung-busting science that you'll only find in the Hackaverse.
Alrighty, so I need you now to see, can you write ICC DIDI, ooh, D got away, to suit exhalation. So instead of being E on top, it would be, instead of being I on top, it would be an E. So pause now and see, can you figure out what are the ones that, the words that you would put in there for this. So hopefully now you've come up with the fact that when you inhale, you are relaxing your diaphragm. You are relaxing your intercostal muscles. Your diaphragm is moving up. And you have a decrease in lung volume this time. And when you decrease volume, you always increase in lung pressure. And therefore, air is going to move out. So I use erudio as my opposite way around. So I'm going to give you a second to pause on that. So erudio, to speak it with a bit of an Italian accent. Now again, the only thing that isn't included in erudio is the fact that your rib cage moves down and in. So that's like your emergency bonus mark. But again, for the process of exhalation, these guys over here should hit every mark scheme. And if you can remember about the ribs, then that will be brilliant. So I'm going to go back and we're just going to finish that little video.
Outwards, the diaphragm will then relax, which allows it to move upwards. At the same time, the internal intercostal muscles will contract. At the same time, the external intercostal muscles will relax. And this forces the rib cage to move downwards and inwards. Altogether, there is now an increase in pressure which decreases the volume inside of the thoracic cavity. As a consequence, we are squeezing the volume smaller, we are going to force air outwards. Let's look at a possible exam question you could get on this. Which row describes the movement of the intercostal muscles and the diaphragm when we inhale a breath? Now, if you know which muscles are going to contract and relax at the right time, you should recognize that the answer is B. When we inhale a breath, the internal intercostal muscles relax, the external intercostal muscles contract, and the diaphragm will contract.
Now, for us, we aren't interested in we don't label our intercostal muscles internal and external. We are just interested in the fact that our intercostal muscles contract and our diaphragm contracts for air to be able to move into our lungs. Now this pretty much is getting us to the end of this lesson. We've just looked at that and we've just gone through this. So we have said your intercostal muscles relax, your diaphragm relaxes, the volume of your lung decreases, your air pressure increases, and your air is going to be pushed out. So as I've said earlier, it is the erudio is what you use for exhalation, and ICC DIDI is what you use for inhalation. So we are going to leave this here. I am on Zoom for you. If you have any questions, these are in our class notebook. You need to put your notes into the class notes section, please and thank you. And we will talk again soon.